AI is a powerful tool.
This summit can help ensure that artificial intelligence charts a course that benefits humanity and bolsters our shared values.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Welcome to today's AI for Manufacturing webinar. My name is Li Hui Wang, a professor of KTH, Royal Institute of Technology. I'm located in Stockholm, Sweden. I'm very honored to moderate today's AI for Manufacturing webinar. The topic of today's keynote is Industry 4.0 and Industry 5.0. How will AI reshape manufacturing automation? We are fortunate to have Professor Xun Xu with us today to talk about this topic. First, I'd like to briefly introduce our speaker. Professor Xu is a professor of smart manufacturing at the Department of Mechanical and Mechatronics Engineering, the University of Auckland, New Zealand. He has been working in the field of intelligent manufacturing solutions for over 30 years. Dr. Xu is an internationally recognized expert in smart manufacturing systems, STEP NC, cloud-based manufacturing, and IoT-enabled manufacturing. He served as an associate editor and a member of the editorial board of a number of international journals and has published over 350 research papers. Dr. Xu is the director of the Laboratory of Industry 4.0 Smart Manufacturing Systems, the only laboratory for Industry 4.0 in New Zealand. Dr. Xu is a fellow of the American Society for Mechanical Engineers and Engineering New Zealand. He was recognized by the Web of Science as a Clarivate highly cited researchers in 2020. In the same year, he was named among the 20 most influential professors in smart manufacturing by the Society of Manufacturing Engineers. Dr. Xu is now on the board of directors of North American Manufacturing Research Institution of SME, in short, NAMRI SME, and NAMRI Scientific Committee, Chair-elect. Ladies and gentlemen, without further ado, please join me in welcoming Professor Xun Xu to the virtual podium.
Thank you, Professor Wang. Hello, everybody. I trust you can see my screen, presentation screen well. It's a great honor to be invited to give a talk at this arena. Very exciting time as AI making inroads into all life of our mankind, and in particular manufacturing, and that's the topic for today. So I'm speaking to you from New Zealand, so it's evening here. I guess some of you perhaps around the world will be other times during the day. But welcome to the session, and hope you get something out of my talk. I guess before I start, I should perhaps manage the expectations of the listeners or the people who join the session. So what I'm saying here is what you may get out of today's talk. Typically presentations like this, and people are looking for solutions. People like to hear observations and perhaps some questions as well in some of these talks. In my case, I don't think I will be offering many solutions, and AI is perhaps one of the solutions that's already on the way to solve all the problems. So I will be perhaps providing some observations, and I'll be raising lots of questions. So that means stay put and stay on after my talk, and we can discuss and debate over some of these questions. So the keywords for today, you've seen the title, Industry 4.0, Industry 5.0, automation for manufacturing and AI, of course. So these are the 4 keywords. I'll stay with these 4 keywords and perhaps divide my talk into 4 quarters if I can. But these are all very big terms, so you might find me jumping from here to there. But just bear with me. I'll come to the end with a cohesive concluding remark at the end. In terms of what I'm going to cover today, I'll just start with very brief background. Professor Wang has kindly introduced myself and explained my background. And then I talk about Industry 4.0, the efforts around doing research in this area, and Industry 4 and Industry 5.0. I'll be just raising some questions and have some discussions as well. Then I'll move on to automation in manufacturing, because automation plays a major role in manufacturing in both Industry 4 and Industry 5. Impacts of AI on manufacturing, I'll touch upon that, of course, and then I'll be asking questions. A very big question, that is, what is a factory for? So it could be a question that you never thought of, but I want to ask this question right at the end. You understand why I do so. I'll finish off with some final words. So my background, I'm actually a manufacturing guy. So I do manufacturing, I do automation. So I'm not an AI person. So you probably will find my knowledge in AI is not as reputable as many others. But I use AI for manufacturing. So really manufacturing is the main field of my research. But I think we cannot get away from AI these days, even with manufacturing businesses. Okay, so let me start with Industry 4. And those who actually have read some documents about Industry 4, and this is perhaps a diagram that come across to you maybe as you first started reading Industry 4.0. So this is coming out of Germany. That's why the way industry is spelled the way it is. Now, there's perhaps no need to discuss and explain this diagram, but what's interesting, you can see from Industrial Revolution 1 to 4, you notice from 1 to 2, it takes perhaps around 110 years. But from second Industrial Revolution to the third, it took about 70 years. And from the third to fourth, it took about 50 years or even 40 years. And so that's the trend. I don't know whether that trend makes any sense, but that seems to have a trend that the Industrial Revolution actually has a shorter cycle as we move on. The second thing I want to talk about is really what's driving all of this. Well, I think one of the key factors is this is what we call mass customization, meaning we're increasingly trying to make smaller, make more customized and fewer products and fewer small volumes and more varieties. I think that's the right words I was looking for. So if you want to have a system that can be made to produce customized goods, you really have to be very flexible. So that's what's driving Industry 4, in my view. So the factories are being made more flexible and smarter. So Industry 4, clearly, as we all know, is originated from a project in the high-tech strategy of the German government. That's back in 2011, so some years ago now. What is Industry 4? I'm not trying to define or giving a unique definition. Well, I think it is fair to say it is perhaps an umbrella term, or is a collective term that try to include some of the contemporary automation and manufacturing technologies. Things like cyber physical systems, CPS, Internet of Things, Internet of Services, data analytics, and of course, artificial intelligence, AI. Well, among many other things, the list can go on and on. Well, you can see here, the key thing here is really focusing on a technological focus. There's a technological push. So that's perhaps what I'm trying to convince you that Industry 4.0 is perhaps a more technological focused term rather than anything else. Well, all of these technologies, if you look at a factory, how do we make a factory flexible, robust, smarter? These are the technologies, but there are many examples out there. Perhaps it's easier to actually have a look at some of the examples that are out there already, then we can understand why Industry 4 is pushing manufacturing into this automation and mass customization era. I thought I should use this smart factory as an example. That's out of Germany, Kaiserslautern. So they have set up a number of smart factories over the years. This one is mobile production plants that's trying to demonstrate some key aspects of Industry 4, looking at collaborative machines with intelligence or artificial intelligence. So what you see here is 4 different workstations. They can be moved around, they can be combined, recombined, reconfigured, depending on what you're trying to do. So here is flexibility. Well, it's okay you reconfigure them, but how do you make sure the system understands the way you reconfigure them? So clearly, communication is one of the issues. We're going to talk about it in a minute. So this is trying to demonstrate how things can be made reconfigurable or flexible. Figuratively, they're on wheels, you can push them around, but in real life, perhaps they're not necessarily on casters and on wheels. Well, the way to make it flexible is actually not to actually use some of the standards PLC technologies. You probably want to use things like service-oriented and decentralized control system because you're moving things around. So control needs to be decentralized. And the production process is actually driven by some electronic data that comes with the components, with the job. So it could be an RFID tag, you scan it, it tells you what job you have to do, and then provide the process plans for doing the job. And the operators in this case, okay, we haven't got operators in this picture, but we assume operators will be here, perhaps working on the assembly workstation or the inspection workstation. So there will be some assistive technologies, things like augmented reality to assist operators to do their processes. So I think in a nutshell, it is a factory that's trying to make things, try to make it flexible and also trying to support operators. So as I said, it is important to actually make sure the communications are right. Well, there are actually standards or the what we call that RAMI 4.0, reference architecture model industry 4.0. So this was part of the industry 4, which specifies different levels of hierarchy in the factory, the life cycle as well. So what you see here is in the hierarchy levels, if you look at a factory, from left to right, the factory makes products, and inside the factory you will have feed device, control devices, workstations, and others. And then of course, and there will be internet connecting everything together. So what you see here is the products that are made by the factory have connections to the factory itself, and everything inside the factory, including people, are also connected in whatever way that's needed. They are connected. So of course, they are enabled by IoT technologies. So what this is really saying is we actually decentralize things, and things are being made connectable in whatever way you want. So it's very important concept with Industry 4.0. If you look at the layers that define all different hierarchy levels, and so the levels here, the layers here represent different business functions, and one of them is the communication function layer. So this layer actually defines different industry protocols that will enable your communications for your smart factories. So what is it? Well, typically people think there's actually an overlapping between Industry 4 and IoT and machine-to-machine communication M2M. And the path that overlap and in the middle is OPCA. So this is the open platform communication unified architecture. So it's believed that this is one of the key protocols that enable smart factories. It is still being developed. And so implementing Industry 4.0 technologies, part of that is to deploy OPCA in different levels. And so this is one of the important protocols that so we need to look into and try to understand. So this is where I want to explain. I want to introduce my laboratory, the laboratory that I've been working in. This is the laboratory for Industry 4 Smart Manufacturing Systems, LISMS for short. It is actually the very first laboratory for Industry 4 in New Zealand and also in Australia. So what we've done is we've set up a lab, which is basically like a small factory. So you have transporting devices, conveyor systems, you have robots responsible for handling parts, you have machine tools. What you don't see to the right of the picture is a storage area and assembly workstation. So it essentially is a miniaturized factory. So this is important that we can actually practice and develop different technologies. And the communication protocols we've used are OPCA, MQTT, among many others. So the way it works is, this is actually one of my students' projects. It was carried out quite a few years ago. You can see the factory has, the lab has got 2 robots. I've got a conveyor, linear conveyor. There is a circular conveyor here. So the workflow is such that the raw material comes in onto the linear conveyor. The KR16 robot will pick it up and placed onto the circular conveyor. And the circular conveyor transport the parts to the other side, and the KR10 will pick it up and load it onto the machine to get it machined. Once it's finished, take it off, either place it in the baskets or transport it and placed on a workstation for assembly purposes. Now, the cell here, it looks like it's fairly rigid, but there's a lot of flexibilities were built into that. What you don't see in this little cell is the mobile robots. So we have a mobile robot as well. So this is the scenario is that if one of the robots breaks down, we can easily reconfigure the system by introducing a mobile robot to handle a similar task. We could also introduce some additional equipment. So there's a feature of extending the capabilities and also the ability to mitigate breakdowns or broken downs of devices or machines. So I did mention about assembly workstation. So the cell has since been upgraded, and this is the edit assembly workstations. My students is working on the assembly workstation. You can see there's a UR5 robot there. So the conveyor has been replaced. There's a camera on the UR5 robots, and they can recognize the parts, and then will be picked up and placed onto the workbench. This is where the human-robot collaboration takes place. So it will be a human person operator working with robots to carry out some complicated assembly tasks. So you can see there are automated features in the cell, but also there are human-centric or human-robot collaboration research in our laboratory. I should perhaps just briefly show this. And for those who are interested, you can scan the QR code or just take a picture of that, and you can go and visit our laboratory. We even have a virtual tour, virtual lab. If you scan that, go on to our virtual lab, you can actually be here and visiting our lab, not having to be here physically. So welcome to visit our laboratory. So that's Industry 4 and also some of the work we've done in our laboratory. I want to come back to this diagram regarding Industry 4.0, and we know just around 10 years after Industry 4 was introduced, and we have Industry 5. So basically, we are talking about both Industry 4 and Industry 5 at the same time. Okay, now, so much so, we think there's some discussions needed to really better understand Industry 4 and Industry 5. And this is why we got together, wrote a paper to try to promote some discussions around these terminologies. So this paper was published in 2021. You can see that the last author is Professor Wang, the moderator for this session. You can see at the bottom here, the paper had a very quick turnaround. So it submitted on 28th of September and came out and accepted 10 days later. It was online another 10 days later. So between the paper was submitted and it was published online, it was 20 days. So we think it is topical subject, and also the timing is right there for us to actually write this paper. So the remaining talks, not remaining, maybe the following few slides will be based on this paper. So we'll go fairly quickly through some of the key points in this paper. For those who are interested, this is open access paper. You can actually go and have a look yourself. You can download the full version of it. Okay, right. So we've talked enough about Industry 4. Industry 5, what is Industry 5? There are, again, as many definitions for Industry 5 as for Industry 4. So this definition is actually from European Union, the European Commission and Social Committee. They had a white paper on Industry 5. So what that is Industry 5 is understood to recognize the power of industry to achieve societal goals beyond jobs and growth. So society goals is key words here. To become a resilient provider for prosperity by making production respect the boundaries of our planet and placing the well-being of industry workers at the center of production process. You can see there is a concern of the planet and also the well-being of the workers. So clearly it is looking at through a different lens, if you like. So there's some key values of Industry 5.0. Perhaps if you try to compare with Industry 4, this is perhaps the most strikingly different. So in terms of core values of Industry 5.0, these are human-centric and sustainable and resilience, as the definition we gave before. So the three key values as we talk about Industry 5. Well, clearly, we're still in Industry 4, and now Industry 5 comes along. So really, there's been a talk about Industry 4 is technology-driven, and Industry 5 is value-driven. So clearly, we have got two industry revolutions coexisting at this time. This hasn't happened in the past from industry, from the first into the fourth industrial revolution. So clearly people will ask questions, and we have a few questions in that paper. So I'll just relay these questions to you, and I'll just speak to them and perhaps trying to provide some discussions and answers if I can. Question 1, to what extent is Industry 4 technology centric and oblivious of human centricity sustainability and resilience. That means ignoring all of this. Is it true, or to what extent it is true? Second question, can Industry 4 technologies help realize goals of Industry 5? And do we still have new technologies to be developed for Industry 5? Question number 3, is Industry 5.0 a chronological continuation of Industry 4, similar to other predecessors, Industry 1 to Industry 4? So this is perhaps an easy question to answer. And another question is, are we living amongst two industrial revolutions or effectively just one? So I gave this one called techno-social revolution. So come back to this at the very end. So the first question is, Industry 4 does it actually address anything to do with sustainability, resilience, and human-centric? Or I just ignore all of this altogether? Well, if you dig into documentations about Industry 4, it does actually address some of the challenges in this area. It talks about societal needs, and talks about energy efficiency and urban production. And it talks about supply chain disruptions. And this is actually pre-COVID. And so it's quite astonishing that some of the words in Industry 4 is very fitting to actually address some of the issues we have during COVID. And the other question is, does Industry 4 address human-centric matters? Well, it appears that some of the technologies and Industry 4 does try to address this. So say human-machine collaboration, human assisted or operator-assisted technologies, and these are the robotic-assisted systems or augmented reality tools. These are all there to actually assist workers with real-time information and others. It does talk about social technical approach, and so work-life balance. It does talk about a lot about upskilling, reskilling, and workers' well-being. So it seems to me that Industry 4 is not ignoring all of this, and maybe it's not a key focus for it, but it does recognize the needs of addressing some of these issues. So if we move on to Industry 5.0, so the concept and core values, as we talk about it early on, industry is trying to achieve societal goals. So that's one of the key things about Industry 5, and really place the well-being of industry workers at the center of the production process. And it's trying to respect the boundaries of our planet, considering sustainability issues. So it does try to shift the focus from the technologies to a system approach. And Industry 5 perhaps is considered to be an element to complement Industry 4. So they complementary to each other. This seems to be a common understanding up till now. So let's come back to the questions I've raised, and hopefully I can somehow answer some of them. So first question, and does Industry 4 address anything other than technology? Well, clearly it has a technological slant and a focus, but it's not oblivious of human centricity and sustainability and resilience. But does promote a shift of from individual technologies to a systematic approach. Second question, and can Industry 4 enabling technologies help with realizing the goals of Industry 5? Well, if you look at some of the technologies identified for Industry 4, the 9 identified by Boston Consulting Group, the European Union identified 6 enabling technology for Industry 5. And if you look at these, clearly there are huge overlaps. There will be some more targeted technologies for Industry 5 to be developed, but there's huge overlap. So on the technology fronts, and Industry 4 and Industry 5 have a lot in common. Question number 3, is Industry 5 a chronological continuation of Industry 4? Well, clearly the answer is no. So it's not a continuation. It's not that we finished Industry 4. Now we are moving on to Industry 5. That's clearly not the case. So easy question to answer, I think. Last question, and are we living amongst 2 industrial revolutions, which well somehow may confuse people, or effectively just one revolution? And I call that techno-social revolution. So this is perhaps another way to look at the industrial revolution that we are in. We give a different name. Perhaps it's one way to tell people to say, look, there's no point to keep on offering new terminologies. And people are talking about Industry 4.5, and now we have Industry 5.0. Are we going to have Industry 6.0 or 7.0 before too long? So I think it is somehow modifying the previous industrial revolution, so we perhaps should not give a new name, but in this case, we give a name to whatever, some sort of umbrella name for these industrial revolutions. So I will move on now. So let's talk about automation in manufacturing. So we sort of packed this Industry 4, Industry 5, but the common thread here is automation. We're talking about manufacturing, so automation in manufacturing is of great interest to all of us. Well, as it turns out, there are a lot of studies about automation in manufacturing, and this is a survey study by McKinsey predicting that 64% of the global manufacturing activities can be automated. So if you do that, you're saving awful a lot of working hours, and you're saving other things as well. But 749 billion working hours, it doesn't mean too much. But really 64% of manufacturing tasks, that's a huge amount. Well, we're not asking question, how do you quantify a job? How do you assess a job can be automated? But there are some interesting questions I want to ask. I want to pose here, perhaps pose to the audience. Question 1, will the trend of increased automation in industry or in manufacturing industry continue in the future? If that's the case, are we going to have lights out factories? That means there are no people in the factory. Well, just like my analogy could be a driverless cars versus people and people-less factories, as we have driverless cars in the future. So will everything be automated? Are we on that trend? Or conversely, are we always going to have people in the factories? Well, no, we're not going to automate everything. We're always going to have people in the factories. If that's the case, automation must carry social responsibilities. how will the techno-social revolution shape manufacturing business in 20 or 50 years? Really, how are we trending in this kind of industrial revolution? And partially because we have AI coming to us with a lot of enabling tools and technologies. So are we going to see a complete new era of manufacturing business? Another question we will ask is, will manufacturing firms continue to exist as an economic entity or a social entity? Well, to a certain extent, if you always have people in a factory, it will carry some social features or social responsibilities. So that's perhaps a more fundamental question that we have to ask ourselves. Last question, how does AI impact manufacturing automation? Well, clearly it will impact, but to what extent, how much it will impact manufacturing automation. Now, all of this perhaps are bigger questions, but I just want to perhaps put them in a graph format for those who actually prefer graphs, and me included, rather than text. I want to put this into a graph which has got the horizontal axis representing the industrial revolutions from first to who knows how many, and 5, 6, and 7 down the track. And then if you look at the jobs, the tasks that one has to do in the factory, so you're looking at the jobs that were done, used to be done by human, and it's now automated. So in the very early days, and this was before first industrial revolution, of course, and most of the work done by humans. There's very little automated tasks. So as we go into second, third, and fourth industrial revolution, jobs are becoming automated. So the proportion of job being done manually has come down quite a bit. Well, if I want to plot a graph, a curve representing automated jobs, it will be something like this. And so automated jobs increase as industrial revolution continues. Well, forget about this cross point there. I don't think I'll draw the graphs as I wanted. The curve should be flattened and to be more flat than it is at the moment. But assume that we are right now here, and somewhere during the fourth industrial revolution, and we actually still have some jobs that need people to do. We have a lot of jobs automated in the factory. Okay, so we accept that, and that's why we need to look at human robot collaboration. We do research in this area. We need AI tools to help to assist this kind of scenario. But the question is, in the future, whether it's 50 or 100 years later, we're going to see factories that all the jobs are done automatically. There's no requirement of human being. It's a bit like car. Now it's you driving your car, and the future is perhaps, I hope, before too long, we have cars driven by itself. So that's a big question. Artificial intelligence clearly will play a role in all of this. So I want to just quickly go through some of the graphs here. This is a study from Deloitte, really, and survey some of the manufacturers and academics and industry, and really there's clear recognition of AI having this impact in the growth and in innovation. But where, in which area? Well, in many different areas, and this graph is showing the areas the most impacted are the areas where you have things to do with the cost optimization, the inventory optimization. So optimization is something that AI is very good at. It's good at doing predictions and surveillance and robots localization, image identification, expert systems, and among many others. And clearly, we still remember that factories will have people. We still know that factory will have people. This is an example of human robot working in the same environments. No guards, no safety gears there, and so this is something that industry is doing at the moment. This is a scenario in Volkswagen factory in Germany. So really, this is trying to create environments and where manufacturing systems having human beings in there. So this is an effort to make sure that no knowledge is left behind. So knowledge in the workers and no human left behind. This is really a societal needs, I think. And we will need to create systems that becomes more flexible. And making manufacturing system faster, adaptable to the system disturbances. So there's a flexibility that can be gained by having people in the loop or in the factory and not just automating everything. So I'm gradually moving into AI area, acknowledging I'm not an AI expert, but I have come across some of really shrewd researchers and experts in this area. This slide borrowed from Professor Frank Park, the president of Robotics Society and Automation in IEEE. So we talk about ChatGPT and BARDs and Bing Chat and all the others, generative AI applications. Really, it's actually just the tip of the iceberg. Well, underneath that, we do have a lot of activities, a lot of technologies that needed, a lot of developments need to be done. So we have data collection, so different algorithms need to be developed, data processing, machine learning operations, software platforms, and hardware platforms. So platform developed hardware platforms and specifically to support artificial intelligence. This is a neural process unit, of course. Just like GPU, that's become very popular. Well, impact of AI or generative AI, we've seen lots of examples, and they actually finding ways of industry. So this is just asking a question whether you're still working on a bin picking problems. So this is really using vision technologies and computer vision technologies, machine learning, try to identify different objects. So there are some tools out there which are pretty smart, actually. So we may need to rethink about manufacturing automation AI tools. So we've been all doing research in this area and try to be smart and develop different tools. So this is actually a very interesting example. This is actually from Adobe Photoshop AI. So it has recently built in a generative fill. So in the system, you load a picture. So that's the picture you loaded. And then you try to increase the canvas, you know. Now you tell the system, this is the area I want to expand the photo. So can you use this generative fill to actually continue this photo for me? And this is what it did. You can see how amazing that is. And it does extend the photo with persons, the rest of the body, and the floor there, and the table there as well. Now, to be able to do this, the system need to be able to recognize is a person. The person is doing a job in a factory. So the factory has got a bench, the tools being used, what that is. Because it is factory, so you're working, you wear work boots here. So it's fairly intelligent there, the tools there. So this is telling me that computer vision, the machine learning technologies working with images has really advanced. So we ask ourselves whether we still need to do research in this area. Maybe we just borrow some of the tools. So I'll just quickly talk about the industrial foundation models. So what is it that make AI so popular, so powerful? Well, the key thing is foundation models, and for industry applications, these are the industrial foundation models. So these are actually the brain of all the AI tools. And if you train the models, you tune the models using industrial data, and it will provide solutions to industry. So that's how AI can easily be made useful in manufacturing. Okay, I'm coming to perhaps some of the key questions I want to finish off with. So what is a factory? What is a factory for? So you have factory to the left, no people there, everything is automated, and the factory to the right, you have people actually working in a factory. So the question is it for economic benefits or for social benefit, or for both? So here is a question, and you may have an answer to the question, but I just want to leave it there. Well, as it turned out, I just came across this paper. I thought, I wonder whether I was the only person thinking about Industry 4, Industry 5, artificial intelligence, and it turns out I'm not alone. This paper published this year was presented in a conference last year, International Conference on Industry 4 and Smart Manufacturing. So what this researcher has done is, what researchers have done is, it's trying to plot Industry 4 and Industry 5 with the axis here, horizontal axis indicating to the left is everything is automated using AI tools, and to the right is everything is human in the loop and maybe less AI there. And then using fuzzy set concepts, and there's a degree of membership. 0 is none, 1 is fully qualified. So this is the graph that I took from the paper for Industry 4. So the curve looks like this. That means at the very beginning, and so if everything is automated, it's fully qualified, Industry 4.0. If it's Industry 5, it will be fully qualified somewhere here and 100% and the human in the loop, but not much automation in there. So I wasn't sort of agreeable to this concept, but I think what's interesting here is this green curve, which is saying this is hybrid industrial revolution 4 and 5. So what this is really saying is somewhere in the middle, Industry 4 and 5, there is a combined scenario for industry. That means we will have people in the factory. We will always have people in the factory. We will not have people-less factories in the future. So I'll leave that to you. And the paper is interesting. There's some other studies, similar studies you can find as well. So I'll finish off with my final words. That is, if you look at Industry 4, okay, that's Industry 4 inclusive of the technologies and values, the concepts. And then you have Industry 5, and we understand, okay, 4 and 5, some overlapping, but they actually exist right now as we speak. So there I say it is actually a techno-social revolution. So it is an industrial revolution that actually consider technology and societal needs at the same time. So I'm saying it's not 4, not 5, but it's a techno-social revolution. Right, so finish off. Just a few quick final conclusions. So the industry revolutions leads to fundamental changes to industry, which in turn leads to economic and societal consequences. So this is important to recognize societal consequences. Industry 4 call for manufacturing to make mass customization to meet this mass customization trend. So really you're trying to make system flexible, adaptable to different customers' needs. It is perhaps fair to say that Industry 4 needs Industry 5 to remind the essential societal needs and value and responsibilities as the ultimate goals. Industry 5 requires Industry 4 for the technological push and solutions. Generative AI tools, they perhaps can offer some free bells and whistles for smart manufacturing. So as I explained there, and computer vision perhaps has really matured some of the generative AI tools that can be used in manufacturing. I think we agree that AI perhaps has 2 roles to play in manufacturing. One is to continue the trends of automation. Well, whether that trend actually will reach a point where everything will be automated, that remains a question. AI can enable human-centric manufacturing. So if you consider human in factory, AI will play a role in there to really enable a human-centric manufacturing scenario. Manufacturing has 2 sides. There's an economic, it can be considered as an economic entity. That means it make money, it make products, it generates revenue. And it has a side of being a social, societal entity, as long as where people in there will have to consider the workers' well-being, the societal needs. So I think that's all I want to talk about this. And as I said, I'm not offering a lot of solutions, but I'm offering some of the observations and lots of questions as well. So questions here, good food for thoughts. So with that, I conclude my talk, and thank you for your listening, and I'll be happy to answer any questions. Almost come to the first 4 hours, but I'll be in the networking session. Thank you.
Thank you, Professor Xu. It's a very interesting talk. Since the beginning of introduction of Industry 5.0 by the European Commission, there has been a number of debate discussions. Of course, this is relatively new after Industry 4.0. People may have different opinions, different ideas. This seminar is for people to discuss this issue, but for us, we really wanted to focus on technical issues, and we will not touch upon some other things not relevant to manufacturing, to AI, and for manufacturing stuff. So now there's some time for the online audience to pose questions. In the chat, there are 2 questions posted halfway through the presentation. Hopefully, Professor Xu already answered your questions. If not, you can either ask a follow-up question or postpone this to the neural network discussion. During the talk, keynote presentation by Professor Xu, there's also a number of thought-provoking questions. Those are meant for two-way discussions. We do not have time to discuss every question, but those can be left to everyone to think about it, and maybe you can come up with a better answer, better suggestions. While you are preparing your questions, perhaps I can ask a couple of them to use the time. I mentioned Industry 4 and Industry 5 has some debate ongoing. We will not touch upon that. But AI is a good tool. And there's a number of AI tools and algorithms. Most of the people are using them for data analysis and making good and wise decisions. So my simple question or general question to Professor Xu is, what are the advices and the lessons learned that you would like to share with the audience during your research in the past years that we better to capture, especially the lessons learned, to avoid problems in the future, if you wanted to share some?
Thank you, Professor Wang. Very good question, and also a big question. Not sure that I'm qualified to give a thorough answer to the question. I guess, as I alluded in my talk, generative AI, doesn't matter what tools you're using, ChatGPT or others or the like, there's a huge amount of work done behind all of this. And the data that used to train these models primarily from the internet, so the great broad internet. Well, that's perhaps reason to that, because ChatGPT and tools like this appear to general public. But for manufacturing, for industry, that's probably not very useful. Well, the only reason it is not useful is because it's not using the industry data to train the models. So what this is telling me is, if you're doing research in machine learning, deep learning, and artificial intelligence, think about it. Perhaps the tools and algorithms are already there, and make sure that if you know that the tools are already there, maybe try to use the industry data to train the tools so that they become useful for manufacturing, as other tools are useful for general public. So that's probably something that I think for all of us need to think about it, and try to see whether manufacturing can benefit from this surge of artificial intelligence. I'm not sure whether I answer your question.
Yeah, pretty much. Follow-up question related to the AI is, the ITU webinar series is AI for Good. This is from the title, you see how to apply AI for the good of a factory, for the society. So this naturally introduces an ethical situation. What if someone not using AI for good? And what is the countermeasure or prevention measures to make it minimized? What's your thoughts?
Yeah, that's a good question as well. That's one question I deliberately not talk about it. Didn't choose to talk about it. It is a question that's in many people's minds as well. It is actually quite relevant for manufacturing as well, because as I talk about human-centric approach, and consider people in the factory, and people will be in the factory in the near future, if not a long future. So there's ethical reasons why care needs to be taken when you apply artificial intelligence tools to assist human operators in the factory. Well, not just well-being, but also privacies and others. Yes, it is a question, I think, in many people's minds, and I think it is something that we It's going to stay with us, that question, for a long time. Any technologies, no, not any technologies, many technologies tend to have impacts in both ways, positive and negative. So yeah, something that we really have to watch out for.
Thank you. So I'm checking the chat box. Any questions from the online audience or the previous colleague wanted to repost your question, or you prefer to leave it for the next work session? Yeah, I think because of the time and we do not have a further question from the audience, I would like to suggest that we leave the further question answer to the neural network session after we close the Zoom session here from broadcasting room. And then you have the opportunity to mingle with the speaker, either in a many-to-many or one-to-one conversation. Before I close session, I also wanted to thank our speakers of today, Professor Xu, for delivering a wonderful keynote talk, and also wanted to thank all of you participating in the webinar online and raise questions for some and participate and digest the questions that are posted by Professor Xu. Our next AI for Manufacturing webinar is scheduled on October 16 at 11 a.m. Central European Time. And Professor Tom Curtis of Georgia Institute of Technology will present a keynote on next generation cyber-secure platforms enabling the democratization of advanced manufacturing. Please stay tuned. Have a great day and bye for now.
Bye for now. See you later.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
AI is a powerful tool.
This summit can help ensure that artificial intelligence charts a course that benefits humanity and bolsters our shared values. Mm-hmm.